Engineering Apex. We uncover the story behind the speed. Subscribe for the deep dive. In the rarefied atmosphere of supercar manufacturing, one variable dictates the limit of performance. More than horsepower, the strength to weight ratio. For decades, woven carbon fiber reigned supreme, yet it carried an inherent, industrial, fatal flaw. It is excruciatingly slow to produce. The traditional autoclave process is a bottleneck that strangles scalability, turning every chassis into a waiting game. Now let's open the factory blueprints and deconstruct the story of this engineering titan. To understand the magnitude of Lamborghini's breakthrough, we must first audit the limitations of the status quo. Traditional carbon fiber reinforced polymer, or CFRP, relies on the meticulous layering of pre-impregnated woven sheets. When we observe footage from standard composite facilities, we see a process closer to haute couture, tailoring, than advanced automotive manufacturing. Highly skilled technicians must hand-lay specific weave patterns, typically 2:2 twill or plain weave, into mold, strictly ensuring precise fiber orientation to handle specific stress loads. When we analyze the labor metrics involved, the inefficiency is glaring. Technicians must align the fibers of every sheet to counteract specific torsional forces. If a layer is misaligned by a fraction of a degree, the structural integrity is compromised. Following this lamination, the autoclave cycle demands up to 6 hours of curing time under high heat and vacuum pressure. This throughput restriction meant that a carbon monocoque was effectively a piece of jewelry, exquisite but unscalable. For Lamborghini, a brand looking to expand its market footprint with the Huracán and subsequent models, the mathematics of the autoclave simply did not work. They faced an engineering ultimatum: sacrifice production volume to maintain the material advantage of carbon, or fundamentally rewrite the physics of how the material is formed. The solution required abandoning the aesthetic perfection of the weave in favor of a chaotic yet scientifically superior method of mass compression. The solution to the autoclave bottleneck did not come from refining the weave, it came from destroying it. When we step onto the production floor of Lamborghini's specialized composite facility, the atmosphere shifts from a quiet, clean room to something resembling a high-pressure industrial foundry. Here, the delicate artistry of hand-laying pre-preg sheets is replaced by the brutal efficiency of forged composite technology, a process rooted in the principles of sheet molding compound, SMC. Unlike traditional carbon fiber, where long continuous strands act as the load-bearing skeleton, forged composite utilizes chopped toe. These are carbon fibers cut into short, precise lengths, typically between 1 and 2 inches, suspended in a resin matrix. When we analyze the raw material before processing, it lacks the recognizable geometric beauty of a 2x2 twill. It looks deceptively like a chaotic, fibrous paste. However, this chaos is calculated. In a woven sheet, strength is orthotropic. It is strongest only in the direction of the fibers. If a load hits a woven panel from an unexpected angle, the matrix can fail. In contrast, the random orientation of the chopped fibers in forged composite creates near isotropic strength, meaning the material exhibits uniform structural properties in all directions. The manufacturing process itself is a study in violent compression. The pre-measured charge of chopped fiber and resin is placed into a heavy-duty, steel mold. Unlike the autoclave method, which gently coaxes the resin to cure using vacuum pressure and moderate heat over several hours, this process is aggressive. The mold, heated to precise activation temperatures, closes under the immense force of a hydraulic press, often exerting over 1,000 psi upon the material. This leads to a critical phase change. Under this extreme heat and pressure, the resin and fiber mixture momentarily behaves like a liquid, flowing into every crevice, rib, and complex geometric corner of the mold. It fills voids that a stiff, woven sheet could never occupy without wrinkling or bridging. But the true engineering triumph is the cycle time. Because the mold is heated and the pressure is so intense, the curing reaction is accelerated exponentially. What once took 6 hours in an autoclave is now achieved in the press in less than 10 minutes. We are witnessing a manufacturing cadence previously thought impossible. For structural composites, the ability to stamp out monocoque components with the speed of stamped steel, yet retaining the lightness of carbon. This ability to make the material flow did more than just speed up the clock. It liberated the design engineers from the geometric tyranny of the 2D weave. When we examine the Sesto Elemento, the manifesto car for this technology, we see suspension control arms made not of cast aluminum, but of forged composite. Producing such a complex three-dimensional shape with woven cloth would require intricate cutting, darting, and overlapping, introducing potential failure points at every seam. With the compression molding process, the material simply fills the void, allowing for variable thickness and integrated mounting points. In a single shot, this geometric freedom culminated in the aerodynamica Lamborghini Adava, or ALA system, found on the Huracán Performante. When we analyze the rear wing stanchions, we find they are not solid blocks, but contain hollow, internal air channels. The manufacturing process allowed engineers to embed these pneumatic pathways directly into the structural composite itself, creating a smart material that acts as both a load-bearing wing and an air ducting system. A woven sheet could never contour to these internal cavities without wrinkling or losing strength. By embracing the fluid dynamics of the molding process, Lamborghini didn't just replicate metal parts in carbon, they engineered complex, monolithic structures that integrated aerodynamic function directly into the chassis itself, proving that the chaotic arrangement of fibers could yield a precise aerodynamic advantage as the hydraulic press releases its grip in the steam. Clears, what emerges is no longer just a composite part, but a testament to the evolution of industrial alchemy. By daring to abandon the aesthetic tradition of the weave, Lamborghini transformed a slow, artisanal craft into a rapid-fire science. It reminds us that in the pursuit of the apex, true innovation often requires shattering the very pattern that defined perfection in the first place.